Hi everybody, I'm Girish Chowdhary. I'm an assistant professor at Ag and Bioengineering. I have other appointments also on campus, including computer science, electrical engineering, aerospace engineering, and coordinated science lab. So I was born in Mumbai, India, to parents who worked full-time. My mother, who was the first woman ever to work as an officer in the Maharashtra Civil Services, came in at a time when parental leave didn't exist. So I spent my early years with my grandparents in Kumta, which is south of India. My grandfather was a university physics professor, and he instilled in me an interest in physics, specifically astrophysics. I later moved to Pune, India, back with my parents, where I attended high school. The school was like what we call a STEM school here in the US. When I was there, my interests shifted more towards aerospace engineering. My school was not far from the region. Farming was something that was part of my life, at least peripherally. So even though I wasn't thinking about the stars, even though I was thinking about stars in space, agriculture was still there. I moved to the Royal Melbourne Institute of Technology in Melbourne, Australia for my bachelor's in aerospace engineering. There I made friends who asked me to join them in Germany for an internship to work on unmanned aircraft. I spent 3 years building the Artis unmanned aircraft in the early days of drone technology. My then boss, Jorg, convinced me that US was the place to go if I wanted to be an aerospace engineer. And he was really convinced that Georgia Tech was the place to go. So that's where I went. And under Eric Johnson, there I did my PhD. And then I moved on to do a postdoc at MIT in Cambridge with John Howe. My first faculty position was in Oklahoma State University, which is, as we know, the joke is that everybody's first time in Oklahoma, right? So I was back in the fields, one could say. I started to think about the problems with modern agriculture and how technology could help. Ask any farmer, and they'll tell you that everything boils down to labor. Finding labor during season can be very challenging. In the US, we deal with this problem with large-scale automation. We use chemicals like fertilizers, herbicides, and fungicides to replace labor. To make a profit, farms have to be very large, with very large equipment and lots of chemicals. This is simply not sustainable. I started to think about creative solutions out of this problem. It seemed like there was a big gap in equipment, like large tractors and human labor. So we came up with an answer, and our answer was decentralizing the tractor, teams of small robots. At first, we thought it was going to be drones that fly in the air, because that was our background, but we realized very quickly that we actually needed to be on the ground and under the canopy, like these robots. Actually, I brought one here with me, and my colleague Chinmay is going to drive it on the stage here. A little bit of showmanship never helped, right? Never hurt anybody. So this here is Terra Sentia, and we like to think that she's a she, and she's 13 inches wide and fits perfectly in cornrows. But the idea was, under the canopy, robots like this could help monitoring, weeding, and spraying. By deploying a small robot or an army of small robots, depending on the size of the farm, we could have cheap labor that can do various tasks on the farm, from monitoring crop health to weeding and spot spraying. This gives growers access to valuable data about crop health and the ability to treat diseases and kill weeds at a whole new level of precision. But what does an aerospace engineer know about agriculture? Finding funding to explain and expand this vision was not easy for me in a mechanical and aerospace engineering department. I was stuck in a world between agriculture and engineering. But then I had the opportunity to interview here at Illinois, and the scientists here at Illinois really resonated with the vision. I was very fortunate to cross paths with an institution that understood my vision. Casey Ting, who's here today, thank you, Casey. The ABA department head at that time when I interviewed saw what I was trying to do, and he saw the opportunity and pushed hard to hire me. Casey now heads our Zhejiang efforts, but visionaries like him are the main reason I'm here today doing this work. Like our new department head, Ronaldo, and we thank him for coming here and joining our department. At Illinois, this vision has bloomed into an invaluable research tool, working with crop scientists like Steve Long, Raynor Gillette, Adam Davis, Herman Bolero, and Carl Bernanke, some of the brightest minds in the biological aspects of agriculture. Our robots can do the research fieldwork required in a fraction of the time. And it's not just the biology side. U of I, of course, is one of the top engineering schools, allowing me to collaborate with experts from engineering. With the Center for Digital Ag and the Center for Autonomy, this has become the perfect storm. But all research and academic aspects aside, I think the big moment for us was showing real people our robots. At first, people were like, they look too flimsy to work on fields. But we showed them how easy they are to operate. We listened to them, and we came to an understanding of what could be achieved with small robots. Our robot is something they could pick up, easily transport, and quickly operate. It was so different from the large equipment they were used to. They realized what a game changer these robots could be. They saw that crops could be managed with the same intensity that one may have in their home garden, but at any scale, small or large. This can lead to decentralization, which allows for flexibility, as well as allowing more people to farm if they want. Right now, farming is centralized to what we know as agricultural areas. Central Illinois is a prime example. But what if we could use more space for farming? Farms could be closer to more population centers. To realize this dream, I co-founded EarthSense with my old school friend and an Illinois research scholar, Chinmay Soman, who is right here with us today. Here's the thing though. This type of innovation takes a lot of financial investment. Sure, we can gather data and write papers, but to really make a difference, to really do this, we need an investment. And Illinois has been great with Enterprise Works and the Research Park. These facilities have allowed us to make our work a reality with our company EarthSense. Illinois is willing to invest in making visions like ours a reality. They get it. The robots that my group has built, like this one that's estimating yield using AI, are being commercialized. EarthSense is deploying these robots with major breeding firms like Corteva and KWS. These companies are using our robots to breed better crops that will sustainably feed the world. At the lab, our sites are now set on autonomous farms that are orders of magnitude more sustainable and put more money in the growers' pockets. We're working on teams of robots that can mechanically weed the fields without using a single drop of chemical. These robots could be the answer to the growing herbicide resistance crisis that we're currently facing here in Illinois and most of the Midwest. On the horizon are also under canopy spraying robots, robots that can plant cover crops, robots that can diversify our crop system, and eventually even let urban dwellers grow vegetable patches in their backyards, decentralizing, flipping around the whole agricultural production system the way we know it. The future of agriculture and agricultural engineering needs a new face. And Illinois is uniquely poised to be that face. We have already shown agricultural engineering can attract those from electrical, computer, and aerospace engineering. I am a prime example. Right now, agricultural engineering may not be the so-called sexy discipline, but we are building our own Silicon Valley here of agriculture here in Illinois. I would say the one big takeaway is that Illinois, as an institution, should invest in this idea. I would say that this investment is going to pay huge returns as we try to feed 9 billion people. Agricultural autonomy, the internet, and general digital agriculture brings the strength of us, Illinois, together. And you know, somebody is going to do it. And I think we should be the leaders. Thank you.